All right, let's talk about the engine, the thing that's really driving this whole AI revolution we're seeing. It's an incredible piece of tech called the transformer. If you've ever played around with something like ChatGPT and just been blown away, well, you've met a transformer. It's the brains of the operation, the secret sauce inside that lets it talk like a human. But how? I mean, really, how does a machine, just a bunch of computer chips, actually get language? How does it understand jokes or sarcasm or just the flow of a conversation? It feels like magic, but it's not. And we're going to pull back the curtain and see how the trick is done. Okay, so the very first step, the absolute foundation of all of this, is realizing that computers don't think in words. They don't know what apple or sky means. They only speak one language, and that's the language of numbers. So we have to translate our world of words into their world of math. This translation process has a fancy name, word embedding. But think of it like creating a detailed ID card for every single word. It's not just a random serial number. It's a whole list of numbers, a vector, that acts like a fingerprint, capturing the word's unique personality and how it relates to every other word in the dictionary. So how do you build that ID card? Well, you can think of it like playing a game of 20 questions. Let's take the word king. Is it royal? Yep. Is it a person? Yep. Does it have a specific gender? Yeah, male. Is it powerful? Absolutely. Each answer becomes a number in that word's unique list. And here's where things get, honestly, a little bit weird and absolutely amazing. Because once words are just numbers, you can do math with them. And I mean actual math. This leads to what is probably the most famous example in all of AI, and it's going to blow your mind. Okay, so let's take the number fingerprint for king. It has all that royalty and maleness baked into its numbers, right? Now, what happens if we mathematically subtract the fingerprint for man? We're basically taking out the very concept of being male. And then, what if we add the fingerprint for woman? We're putting the idea of femaleness back into the equation. What do you think we get? King minus man plus woman equals queen. The math just works. It's incredible. The model figures out these deep relationships all on its own. It's literally word algebra. Okay, that's amazing, but there's a catch. A big one, actually. This method gives each word just one permanent ID card, one static meaning. And if you think about how we actually use language, well, that's a problem. Yeah, just look at the word track. You could say, the train is on the track, which is a physical thing, or you could say, help me track my package, which is an action. Same word, totally different meanings. A single number fingerprint just can't handle that. So, what's the missing piece? It's context. The model has to know what a word means in that specific sentence. It's not about the word by itself, it's about the company it keeps. That's the key to real understanding. And this context problem was a massive wall for AI researchers for a long, long time. They were stuck. Until a new idea came along that didn't just climb the wall, it blew right through it. And that idea was called attention. Seriously, the research paper that introduced this was called Attention is All You Need. How cool is that? It wasn't just a clever title, it was a statement. They were saying, forget everything else, this mechanism is the secret. And it became the heart and soul of the transformer. So what is attention? It's pretty much what it sounds like. It's a way for the model to look at a whole sentence and, for any given word, figure out which other words are the most important for understanding its meaning. It learns where to focus its attention. The classic way to explain this is the library analogy, and it's perfect. Imagine you walk into a library. The topic you're looking for, say artificial intelligence, that's your query. Now, the librarian doesn't read every book. They scan the shelf labels, the keys, looking for things that match your query. When they find the right shelves, they grab the books, the value, and give them to you. The model does the same thing with words to find the most relevant meaning. All right, so we've got our building blocks, right? We have word embeddings, turning words into numbers, and we have the attention mechanism, figuring out context. Now, let's put it all together and see how the machine actually works. A transformer is basically made of these things called blocks, stacked on top of each other. Think of each block like a station on an assembly line. A word's number fingerprint goes in. Then this thing called multi-head attention gets to work. It's like a whole team of experts all looking at the word from different angles. One checks grammar, another checks meaning. Then all their notes go to a feed-forward network, which is kind of like the supervisor that processes everything. And what comes out the other end? A brand new, supercharged number for that word, now packed with all that juicy context. And that multi-head part is no joke. We're not talking about 2 or 3 experts. A big model, something like GPT-3, can have 96 of these attention heads working at the exact same time, each one a specialist, looking for a completely different kind of connection in the sentence. But wait, there's more. That new context-rich number that came out of the first block, it immediately goes into the next block, which does the whole process all over again, but on an even deeper level. And big models stack dozens of these blocks, each layer refining the meaning more and more and more, creating this incredibly rich understanding of the language. So let's take a step back. After all that, the number fingerprints, the attention, the stacking of all these layers, what's the end result? What did we actually build here? What we've built is, at its heart, an incredibly sophisticated prediction machine. It can look at a sentence, understand the context in this deep, layered way, and then make a fantastic guess about the most likely word to come next. And then it does it again for the next word, and the next. And before you know it, it's writing paragraphs and answering your questions with text that feels, well, almost human. So, in the end, the transformer is what taught machines to see the patterns in our words. But it leaves us with a really big question, doesn't it? We've taught them to understand our words. What happens when they start having ideas of their own? Where is this all going?